So the turbine flow meter is what we'll be looking at next. The turbine flow meter actually have a section has turbine in it. Okay, so this turbine, it has a set of blade which can rotate when it is impinged upon by the fluid that is flowing through this section of your pipeline. Okay, so this is the flow conditioner to help us to have as much as possible laminar flow. Okay, so directing the fluid onto the blade. Are we getting it? So the between these two blades, a specific volume, okay, would have passed this section of the flow meter. So what this is a pulse counter, okay? So what this pulse counter does is that it counts is a pickup anyway. It counts the number of times each of these blade pass through it. So when each blade pass, it generates a pulse. When each of the blades pass, it generates when another blade pass, it generates another pulse. Okay, so the number of pulses compared to the unit, that is the time that it takes for those pulses to be generated, will give us the flow rate, the volumetric flow rate. Remember, we said between two pulses, a specific volume would have passed through the turbine flow meter. Okay, so let's say between two pulses, we have 2 liters would have gone through the turbine meter. A pulse. So if we have that is a pulse now, between two pulses makes a pulse now. So if we have 10 pulse, it means that we have 20 liters of fluid, okay, gone through, that means 20 liters of fluid have gone through that section of this section of the turbine. Okay, so the time it takes for us to generate that 10 pulses, assume is 5 seconds. Okay, so that means we'll have 20/5. Okay, that will give us 4 liters per second. So that will now be the flow rate through that section of the turbine. So in the turbine flow meter, we have turbine, okay, in it that turns when it is impinged upon. That is when the fluid flowing through the pipe strikes on it, it turns it. Okay, so the volumetric flow rate increases. Okay, that is the number of pulses, like we said earlier, increases with the flow rate across this section of the pipeline. Okay, so this will, at the end of the day, give us the volumetric flow rate. So these pulses that is sent to the meter now, or the transmitter, they give us a direct reading of the flow rate, putting into consideration the number of pulses and the time it took. So the calculation is done here, okay, saving us the stress of doing it manually. So that is what you are seeing. So as you watch, you will see that as the flow rate is increasing, what happens to the signal? You see that it is going up. Are we getting it? So this is an example of the flow meter now. Okay, the turbine flow meter. We have the turbine in here that helps to generate that pulses that is picked up and then converted to flow rate in the flow computer. Okay.